And so the next question was, so we've sorted out the camera and the electronics don't change, but what about the fluorescence source? So we thought about various options. You can buy fairly cheap lasers, but the problem with lasers is not just the safety aspect of having laser light emitting from the objective up towards the ceiling in front of students. That's not ideal from a safety point of view, but also they actually add a lot to the size of the system, and they start to need external optics outside of the block, which we were trying to avoid. So we decided to go the LED route, and so this is a commercial LED system you can buy from Thor Labs. I think it's about, I don't actually know the dimensions. I'm going to guess 20 centimeters by 15 across. It's quite a big thing. So again, quite a big lump on the desktop. And you can see how it works. It's got these 4 channels of blue, green, red, and UV, and these are all mixed together using this nice little dichroic system, so that they all fully fill the back aperture of the objective and give you a nice source for your fluorescence imaging. But the problem is, yeah, even this system, even though it's based on quite cheap technology, you can still spend quite a bit of money for it. So so we went and developed our own version of that, which is based on obviously commercially available. It's not a great picture of the LEDs, I'm sorry about that. This is the CAD version of it, and you can see that there are 4 LEDs here, and these are all essentially pushed into a plastic printed mount with 3 custom cut dichroics and a little collector lens. And this thing is tiny. I mean, it's you can see the pound coin there. It's a very small emitter, and so small in fact that we can use quite a high a short focal length lens here and stick the whole thing inside the block of the WOSM, keeping the footprint small and also keeping people away from bashing it and knocking things out of alignment. Okay, and the way it works is exactly the same. You have so you have a red LED here. Sorry if you can see my mouse. The red LED and these dichroics are both long pass as far as the red is concerned, so they go straight through. And then this is this dichroic reflects the green, so the green LED here reflects and then hits this what appears like a yellow filter here that allows the green and red to pass through. But the blue end of the spectrum down here, which are the UV and the blue, all go through this way. And the tricky part really of designing something like this is getting these emitters where you want them within sort of 100 microns or so. And the reason that's tricky is because it's a 3D printed part, so you need quite a fairly small printing nozzle to do that. But you know, it's quite doable, and so with a few iterations of this plastic part, we sort of got all the LEDs to nicely align in the image produced by this collector lens, but also appear at the same size, which is effectively saying the same effective distance from this lens. Yeah, and then finally we got the whole thing mounted on a heatsink, which means that we can run all these channels at their rated maximum, which is sort of 700 milliamps, without things getting hot. Okay, and that's essentially it. Okay, and yeah, as I say, the thing fits inside the WOSM, and in terms of emission, it's also fairly clean, and it's part of the nature of LEDs that they do produce quite a nice, reasonably narrow Gaussian output. If you look at the UV LED at this end, hopefully you can read the nanometers at the bottom of the screen. So I just put the I put the output complete with the excitation filter on a spectrometer and looked at the output, and you've got the UV, the blue, green, and red all running to give me a similar sort of size peak here, so you can compare them all. So the emission filter, the excitation filter, does clip a little bit of the blue here, and it also clips the back off the red, but you lose very little lose very little power there. What is the most affected actually is the green, and it's partly that it's hard to get a nice clean green pure LED in this that centers on this wavelength. So we had to go with a phosphor-based green, and that gives you a much more broader emission profile. And it's so broad, in fact, there's a tiny bleed into the red. So there's a tiny amount of crosstalk, and it's the only one in this whole output. There's a tiny bleed, which is roughly 1% of the green light goes into the red channel. But otherwise, it's a very clean output.